Okay, Shep.
I'm Aaron. I'm the PLF for this class, so if you're an AAP student, this applies to you. If you're not, you don't have to choose me. So basically, AAP enrollment for this class is open, yes, actually, and so you can sign up on my UCLA for any of your PLF times that you're interested in. The times are on my UCLA, and I'll be here after class if you have any questions about enrollment or any other years about attending sessions. Thank you guys.
All right, well, welcome. And I'm really sorry if you were working on the homework last night and you got weird error messages. Like I told you at the beginning, this is a brand new set of materials that puts together all these technologies. And yeah, there are going to be some growing pains. But how many people have been able to get in and start the homework? Raise your hand if you have. Who has not gotten in and started the homework? Is that just because you haven't had time? Okay, you guys need to get in and start the homework. The first week of homework is not going to be that hard, but the second week of homework is like a week and a half worth of homework. And so you really need to get into that, and there's a quiz at the end of that second week also.
So it's like each
But we are going to spend some time at the beginning of the class today talking about questions like homework, how you get credit, how do you know if it's been completed, and so on. How will coding questions be asked during the quizzes or exams? That's a really good question because it's very hard to teach coding at all with a class of 200 students. But if anybody's taken the practice quiz for Chapter 1 and Chapter 2, you've already answered some coding questions. So you know the answer to that. You'll get multiple choice questions that'll ask you, which code produced this output, or which output could have been produced by this code, or what's the problem with this code, and stuff like that. Our coding questions are pretty easy, but the best gauge to you of how hard the real quizzes are going to be and the final exam are going to be are the practice quizzes and the questions that you're asked in the book as you're going through. So we're not going to like suddenly give you a different kind of test that's like super hard. If you can do the questions on the practice quizzes, then you'll get a sense of what the questions are going to be like in the actual quizzes. Let me just quickly see almost all these things. How to make the screen brighter, I called AV, and I said the screen is really dim, and they said, are you sure that the lights are dim in the room? And they are, right? They're dim. You don't want them any dimmer than this or you fall asleep. So sorry, we'll keep trying to make the screen dimmer. Another question that people have come up with is, well, we've gotten some really interesting questions. One of the questions is, where's the homework? I went through the whole Canvas thing and I didn't find the homework. That is the homework. That's the beauty of this. So if you go through and you read things and you think about them, and you write a little code, and you run it, and then you write something, and then you answer a multiple choice, you're doing the homework. That is the homework that you're supposed to do. So the whole reason for that is for you to learn. It's not to just hand in homework. So we can see what you're completing, and you'll get credit for completing that. But that is the homework. The other thing is the practice quizzes are part of the homework. They're not the same as the quizzes. They both have the word quiz in them, so that's confusing. But practice quizzes are just for practice, so they're part of the homework. So you need to do the practice quizzes, but you're not, it's not, you just get participation credit for that. Let's try one more Poll Everywhere question. And this is to make sure everybody's connected and that I can connect your Poll Everywhere data to your other data. That's one of my hard jobs, is figuring out how to keep track of everything that you're doing between Poll Everywhere and Canvas and the UCLA website. So when you put your student ID number in, you look up there, you should see it pop up there. So try to watch and see if when you put it in, it pops up. That's a good indication to you that your Poll Everywhere message is getting through. Is anybody still think they're not registered for Poll Everywhere? Raise your hand, don't be shy. Okay, are you guys having trouble getting registered, or you just haven't figured it out yet? You're not enrolled. You just enrolled, okay. If you're still having trouble or you need to enroll in Poll Everywhere, see me after class and I'll let you know what you need to do. I now know what I should have told you last time. few more people, and then I'll. Yeah. Okay, I'm going to definitely talk about that. A lot of you have that question. So how do you know your homework is safe? First of all, last night we had a big crash. So it was a huge mess. They put a new version of that testing software called Learnosity out at 9:30 last night. And you guys are great because somebody immediately wrote. And I woke the guys up out in Utah, wherever they are, and they were up till 4 in the morning because nobody could save any responses. Most of you were probably sleeping. But I was like up worrying, like, what if it's not fixed by tomorrow? So the way you generally can tell is it'll save your answer when you submit your homework. And like if you go back into the page and scroll up and down, you'll see your answers, the things you wrote, the choices you chose, and also what are the correct answers to the question. It's a fantastic opportunity to help you study for the exams, is to go back through the pages and see which ones you got wrong beforehand and so on. Now, sometimes there will be glitches. If you get an error message while you're in Canvas and doing a question, try to take a screenshot of that error message and send it to me. It'll be very useful. But in general, and then write a note in your notebook saying, I did one on page such and such, and I don't think it gave you credit. And then at the end, if you think there's a problem, we can talk about it. But we're going to be pretty good at figuring it out because we have a lot of information coming in. Okay? Anybody else not put in their student ID number? Some people in here did it because there's only 180. I'm going to leave that open. Please go ahead and put it in. So I want to spend a little time today talking about how the course works and answering questions that I've been getting emails about and things that I wasn't able to get to last time. And then I'm going to talk a little bit about the practice of data analysis. And then for a lot of the lecture today, we're going to do an exercise in class working on tables, data tables and presentation tables, which is one of the main things we're working on this week in Chapter 2. So first of all, what counts in this course? The only things that really count are the 5 quizzes and the final exam. That's 80% of your grade. And everything else you do in the class is only to help you learn so that you do better on the quizzes and the final exam. So you can go through the homework and get every question wrong, and you can still get an A+ in the class, if there's such a thing, I can't remember. But you'll get no points off as long as you do all the homework and come to class and do all the poll everywhere polls. So you will, which is another reason to put your ID number in this poll today. If you don't show up as being in poll everywhere, you won't get participation credit. So anyway, but that's our whole philosophy. Everything we're doing just to help you learn so that you do better on the quizzes and the final exam. And if you're going through some materials and doing the practice quizzes, you should be able to ace this course because the questions aren't going to get a lot harder. Now, the topics get a lot harder as we go through the course, naturally. The things we're doing now are kind of easy. These are all the things that we have. Obviously, the online homework, as I said last time, plan 6 to 8 hours a week for that because you don't want to just go click, click, click. You want to read, you want to think, you want to click, you want to check the answer because you don't get penalized for that. Say, no, that was wrong. I'll try another one. It'll let you try a couple of times. Be thoughtful as you're going through this textbook because there's just a lot of ideas in there and some of them are pretty deep. Lectures are going to focus on talking about the most important things. I didn't mention it last time, but we have study halls set up 10 hours a week. And if you look at the syllabus, you'll see the schedule. Every day there's 2 hours of study hall. And I'll talk about that more in a second. Friday labs. Every other Friday is a quiz. And so if you definitely have to be there. The Friday labs are optional. Other than that, they're kind of like the study halls. They'll be run the same way. Office hours. And also some of you have friends. Some of you may not have friends. But if you have friends, especially if they're in this class, talk to them about the class, and that'll help you. All right, things about the online homework that I've gotten questions about. First of all, it's a beautiful slide, I have to say. There's 2 kinds of interactions you're having here. Data Camp, which is the writing the code, and Learnosity. When you write code in Data Camp, we can tell that you completed it, but we don't save what you write, and they don't either. And a good thing about that is if you want to go back, you can redo the exercises again when you're studying for the quizzes and stuff, and practice doing the programming exercises. Remember, this isn't really the way you would use R if you were doing data analysis. You wouldn't use DataCamp. So you would use a system that saves everything you write. You can save the scripts in a file. You can pull them up later and so on. But this DataCamp, this is not going to save your work. It's just a way for you to learn. Yes?
So we don't need to install RStudio?
You do not. Did you get that idea anywhere from reading that you needed to? Okay, good. You do not need to install RStudio, but if you want to install RStudio, you can. And we'll even help you do it. I think we included some instructions maybe in the campus course on how to do that if you want to. Because you're going to be all become R warriors, and you're going to want your own RStudio. It's free, by the way. Learnosity questions are different. Like I told you, they'll save your answers. But again, the sole purpose in all this homework is learning. Mistakes don't hurt you at all. They're really great for you because when you make mistakes, you know what to talk to people about. A number of people still ask me, where are the deadlines? If you look in the syllabus, this is the first 4 weeks. There's a whole table in the syllabus. It tells you for each week of the course what's happening in lab on Friday and what's due Monday. So chapters 1 and 2 are not actually due until this coming Monday, 11:30 p.m. And then the following Friday, April 13th, you can see we have a quiz that goes up through chapters 1 and 2. So it's all laid out there. If you have any questions about it, definitely ask. But I think it's pretty clear. We keep making it clear. Study hall schedule. I posted an announcement with the revised schedule because they keep changing the rooms, but these are the study halls. So the thing is about study halls, don't go to study hall just to get all the answers to the homework, right? That would be stupid, right? Because then you're not going to learn anything. The whole goal of doing the homework is not to get the answers, because you don't even get more points if you get the answers. It's to learn the material. So a really good way to do it is study on your own, get the wrong answer, submit it, and then talk to other people or the TA about, hey, I'm not getting this, what's going on? And that's how you're really going to learn. Very exciting. But don't worry about answers, worry about learning. I told you about the class notebook. You're also going to be able to take the R cheat sheet. If you haven't done that yet, right now I urge you to download the R cheat sheet. I put it in an announcement, and it's also in the resources section of Canvas. It's a really great cheat sheet. We made it ourselves. It only includes the R we're using in this class. It fits on 2 pages, so that should also make you feel kind of good, like everything we have to learn fits on 2 pages. That's really fantastic. Okay, but those are the things you need to bring in. So you should be focused on creating really good notebooks. So, and one thing to consider is whether you want to have your laptop out and your notebook out. I would suggest putting your laptop away unless you really need it to respond to a poll everywhere question. And keep your notebook front and center, because that's going to help you learn more. Wow, okay, say what? How many people noticed this say what thing? If you read the first part of the course materials, this is a little Chrome extension that we're using to get feedback to improve the course. Now, one person, how many people have installed say what? Super, that's awesome. One person wrote me and asked, are we supposed to put a rating on every single paragraph in the course? And I said no, because that would be ridiculous. It would take forever. And I would feel really terrible if I found you did that. So what we want you to do is, if you read a paragraph and go, this makes no sense, or they're telling me this stuff, but they forgot to tell me what the words mean. You know, anything you notice that needs to be improved about the text, put it in say what. And that comes directly back to us. And it's really useful, because one of the things you're doing is you're helping us figure out how to make this course better in the future, which sort of implies it's not very good now. We're okay with that. We're just doing our best, okay? But if you can help make it better for the future, that'd be great. So the instructions are pretty simple in terms of how to install it. And once you install it, you'll have that little gray icon at every paragraph you read. And all you have to do is click on it, and you can rate it from really confusing to really clear. When I first got this extension, we only had 3. They started from confusing and went up to so-so, because I don't really care about you telling us that it's a really great paragraph. because we can't do anything about that. But if you tell us it's a bad paragraph, we can fix it. Read the syllabus. All right, so now, any questions at this point? I think I answered a lot of the questions about how the course is going to work. And trust us, that's really what we want. Everything we're doing here is just to get you to focus on this material and dig into it, hopefully find it interesting, and develop your understanding slowly over the course of the quarter. So today, though, we're going to start by talking about data. And data is the subject of chapter 2 in the textbook. And last time I told you that our view of statistics is that statistics is the study of variation. But you can't just study variation in the world. You have to somehow turn it into data, because otherwise you don't actually even know what you're studying the variation of. And so everything we're talking about today has to do with how you take data from the world and turn it into, how you take variation in the world and turn it into data. And things we're not going to talk about today that are critical, that you have to pay attention to in the textbook, and there'll be questions about them, is, you have to decide, as I said last time, which variation and what are the units that you want to look at variation in? There's a lot of senses in which no two events and no two people and no two anything are exactly alike. No two snowflakes are exactly alike. So as soon as you take a sample of snowflakes and say we're going to measure how big they are, you're missing a lot of important things about snowflakes. Well, you can say, well, it's not about how big they are. It's about how shapely they are, or how many holes they have, or how many crystals they have, or whatever. But you say, well, no, we're just going to measure, how far across they are. Anything like that in statistics is the same way. You have to decide what those units are and which ones you're going to say, for purposes of studying variation, we're going to say these are basically all examples of the same thing. So last time I talked about the last play in the Super Bowl in 2015. And to study that as a statistical exercise, you need to say, what are other plays in football history that are just kind of like this one? We can group them together and look at variability. Because as soon as you group them together, then you can begin to say things like, what percentage of the time do people even try to pass? What percentage of those passes were incomplete? What percentage were complete? And all that depends on your being able to define a sample. And then once you define a sample, you have to look at what attributes you're interested in and how you're going to measure them. And we talk a lot about that in the text. All of this and everything in this course is going to always be related back to the practice of data analysis. When we set about to design this course, this is what we want you to know how to do by the end of the course. We have another picture that I showed you the first day, which are the core concepts we want you to understand. I should have brought that. I'll bring it next time. Because actually that picture should be in every lecture, and this picture should be in every lecture. By the end of this course, we want you to be thinking like a data analyst. And a data analyst does these things, and this is really all they do. Well, they also, go home and go out and stuff like that. But mainly, the core of data analysis is all this stuff that happens once you have data. So you explore variation in your data, you model it, and you're going to learn what a statistical model is and how to construct one. And then you try to evaluate your models and compare different models and say, is this new model better than the old model, and so on. On the left end, you have to somehow push the data into the system. And I don't know how those two little blue dots got there, but I have an interpretation for them, which is that's the little bits of data. They're so excited they want to get into the data analysis system, so they're like jumping in. And then on the bottom over here, and this is all, there's so much here to learn. By the way, I've been doing this whole thing probably for 40 years, and I'm still learning how to do every part of it better. So you'll never learn this stuff, but everything we do can relate back to this. And at the end, of course, you want to tell your story. Make your predictions. You want to tell people, oh, here's what you should do in this situation. You should pass because you have a probability of X or Y that you're going to succeed. So this is the practice of data analysis. And today we're going to stay over here on how do we create data. So at this point, we have an exercise that we would like to hand out. And this is going to probably take half an hour to do this exercise. And I want you to work on it on your own. And you're going to need a pen, and you're not going to need a laptop to do this exercise. It's not a test. It doesn't count for anything. But it's a table exercise. So please take one of the handouts and look at it. It's 6 pages. And figure you'll have half an hour to do it, so kind of don't get too totally bound up in the first question for 20 minutes. Although the first question, you could probably spend longer on it. Yes? You can. Yeah. You can use pencil. Pen's a little easier for us to read. Yeah. Okay. I mean, this is not a test. This is just an activity. But we'll read all these, not for any purpose except to figure out what you're thinking and what's the best way to learn about some of these concepts. What you're confused about on this assignment. So only if you're done. If you're not done, keep working. So this is something for you to think about if you're done with this assignment. What are you curious about? And what are you confused about? And if you're still working on it, try to ignore this other conversation. And if someone else has your question, feel free to vote it up. That'll increase the likelihood that you can attend to it.
Sufficient.
How many people are still not finished? Right. Okay, let's take 2.5 more minutes. Try to write quickly. pencil and draw a line so we can tell that you stopped there. Not that you just couldn't do it, just where you were when you stopped. And hand your papers to the aisles. The TAs are going to collect. And then we have one more whole effort question.
I think it could go either way. Some of them went that way.
Oh, yeah. Have you read the part of the textbook about tidy data tables yet? If you have, answer yes. If you haven't, answer no. We're just curious. Again, none of this stuff means anything to the grade. It's just helping us know where you are. All right. That's okay. But this is a good reason why I'm saying get your homework going early, because then you'll be able to take more advantage in class. Although it doesn't matter. If you're confused about something in class, you'll have more opportunity to learn about it at home. So let's talk a little bit about tables and tidy data tables. But first of all, let's talk about variables. So we started out by giving you a survey question. So, for example, you consider yourself a morning person, a night person, or neither. What kind of variable is that? Is that quantitative or categorical? Okay, so people make lots of distinctions. Probably in your previous stats class, you talked about you talked about interval and ratio, and there's different ways of categorizing variables. The only ones that really we're going to care about are quantitative and categorical, because those really make a big difference when you're going to make data tables and also analyze data. What about, in general, how good is your sleep quality? Categorical or quantitative? Depends on how the question's asked, right? So in this case, we asked, is it good or poor? That's categorical. If we said, how many hours of good sleep did you get last night? That's a quantitative variable. If we said, rate your sleep quality on a 10-point scale, we would usually analyze that as a quantitative variable, because there's no reason to think that the distances between that scale are different across the levels of that scale. How many hours of sleep do you normally get on a weekday? Quantitative or categorical? Quantitative. What level of stress have you been feeling lately? Normal or high? Categorical. How happy are you in general? How happy are you guys? Okay. You worked really hard on that, by the way. Thank you. Do you have siblings? Check all that apply. That's kind of a tricky variable. Have you answered questions like that before? Okay, so is that a categorical variable or a quantitative variable? It's a categorical variable. How would you put that in a data table? Who's got an idea? And I mean in a tidy data table. And let's actually, before you even answer that question, let's talk a little bit about why we're even talking about presentation tables and tidy tables. It turns out that, first of all, what is a table? I looked around the room and I saw people making bar graphs and scatter plots, all kinds of things. Those aren't actually tables. Those are graphs and plots and charts. But a table is got rows and columns. And tables are used all the time. I actually prefer graphs for most things, but tables are used all the time, and they're used for two different purposes. One purpose for a table is to present your results. So we actually had some results presented in this study. We said, how would you present those results in a table? And there are options, and hopefully you found some options about how to make that tables in different ways. But computers don't read the tables that we typically use in presentation. So typically, when we're doing presentation, we design our tables hierarchically. I'll show you some examples in a second. But computers don't analyze that data that way. Computers need to analyze what they call flat files. You can't have hierarchical ones. You have to have flat files. And that's what tidy data is. It's a convention for how to organize the data so that it can be analyzed by R. Now, why is that important in this class? Is because you're going to be analyzing data with R. So you need to learn about tidy data. But the truth is, every software has its own data formats. R is an open source programming community, so it's like the Wild West. So somebody got the idea, hey, let's try to get everybody to put their data in the same basic format. So if people write new data analysis routines for R, they'll all work because everybody's data will be in the right format. And that's why tidy data are so important. So think for a second about do you have brothers? Do you have sisters? How would you put that in a data table? First of all, what would the rows be in a data table that you were making out of this? Assuming a data table, and not a presentation table, a data table has columns and rows. What would the rows be that would result from this survey? Who has an idea? Yes?
Maybe like the data collection.
Yeah, but what's a row? A row is what? It's obviously data, but it is, what's a row? Yes? Yeah, each person who answered the questionnaire is going to be a row. And across a row, the data in a row are all bound together. You can't, for example, if you have a lot of rows in a data table, and you just sort the data based on row or on column 1, you need it to also sort on all the other columns. Because if it doesn't, the data will be dissociated. So, you know, somebody who's, if you sort by happiness, but my, you know, stress level and my sleep quality doesn't go along with that, suddenly you've broken what's called the binding in the data table. So you're lost then. You know, no statistics are going to help you get out of that mess. So each row is going to be an observation. And each column in tidy data is going to be a variable. So in the case of, do you have siblings? Check all that apply. Brothers, sisters. Would that be one column or two columns? Who thinks that would be one column? Come on. Who thinks that would be two columns? All right, who says one column? Yeah, tell us about that one column.
Oh, because it's just a single value for whatever that is.
What would the value be? What if I had a brother and a sister? What would the value be? Well, if you only have one row, you can only put one number.
Maybe you can tell R like brothers 1, sisters 2, or both.
You could do that. You could. That is definitely true. You could recode the variable and have brother be 1, sister be 2, and both be 3. Okay, that's great. Who answered 2 columns? That's good. 2 columns is good. How would you put your 2 columns?
So you would have like brother in one column, sister in the other, and that way you can add multiple. You could put like your brother 2 and your sister 1, 0, 3, 7.
Okay, but you're not going to get that. And the reason is because you've got to go back to how the question was asked. That's why it's so important to constantly, as a data analyst, look at your actual question, look at your data table, look at the question you're trying to ask. Like, yeah, that would be great if they had asked, how many brothers do you have from 0 to however, and how many sisters do you have? And then you could have totaled those up, but they didn't ask that. They said, do you have siblings? Check all that apply. So the most you're going to get is have at least one brother, at least one sister, or both. Or none. Yeah. So you could have 2 columns where you have brother, yes or no. Sister, yes or no. And then you don't even have to have a column for both because you could compute that column. You could say if brother is greater than 0 and sister is, or you can just add them up and say, oh, it's a 2. They have both. Or you could say if brother is greater than 0 and sister is greater than 0, then give them a 3. You can do all those things. But You can't recover data that you don't ask about. So if you ask somebody how stressed they are and the choices are normal or high, you can't go back and get a rating scale of how stressed they are. You have to go ask the question. So you've got to constantly go back. And as a data analyst, this is really important to think about the details like this. And actually, this is going to be true later in the course also as we get into statistical models. I told you, we're not going to be calculating things, but we are going to get pretty detailed about what's actually happening in the background, because that's how you know what you're really doing in a data analysis. So what is a presentation table? Here is the presentation table. Fewer night people have high stress than morning and neither during the school year. And night, morning, and neither have the same stress during the summer. Okay, so question. The number in the cell marked A represents what? What does that number represent? Think about it. All right.
It's like people that fit in all those categories. So if there were 19, there'd be 19 people that are morning people that have high quality of sleep and that are highly stressed and so on.
How many people have another idea of what would go in that cell, other than number of people? What is your name?
Maggie.
Maggie? Maggie says number of people. Does anybody have another idea of what could go in that cell marked A? Yes?
I think like because like for that person, it could be like the rating of stress, like stress from 1 to 10 and 10 being high for stress.
Okay, but again, how was stress asked in the interview? It was just normal or high. So we don't have a rating. We just know whether they were normal or high. You see what I'm saying? How that variable is measured is going to totally depend on how you can create this table. Did you have another idea? You could put a name of an individual that falls in that category, but is that a good way? Remember what a presentation table for? It's to present your results to the world. You're going to tell them the story. If you start putting people's names in there, do you think people care who the people are? Like if I'm reading about a study in the newspaper, in the New York Times, and suddenly it says, oh, well, Maggie was high stressed and a morning person, and this other person. No, people don't care about that. And they don't find it convincing because they say, well, that's Maggie. What does that have to do with me? Okay? So presentation tables are to summarize a pattern or a distribution in your data. Okay? And if you're reading in the data, distribution, core concept. It's the pattern of variation in a variable. Yes?
You could put summarize the data in terms of ratios. So maybe 60%, I mean 60% is high stress, and then the normal column would be 60, so the other one would be 40%.
Interesting idea. You could put a proportion in that, like the proportion that were high stressed, and if that were 60, then or 0.6, and in normal it would be 0.4, but actually, you know what? You don't even need both of those, do you? If you know that 0.6 are high stress, you know that 0.4 has to be low stress, and maybe you could cut that column out of your table and make it even a little simpler. So that's actually a really interesting idea. Yeah?
It could be a number that represents a certain amount. So they said that based on like fewer night people have high stress than morning and later in the school year. So it could be, okay, well then morning people are 1% yes, or morning people have high stress. And 2 would be
Yeah. Well, I'm not sure exactly how that would work because you're going to have many people that fit in that cell. So they're not all going to be either ones or twos.
It's just people would be able to represent like their body and stuff. They're saying that, oh, okay, so like based on these general, then morning people have high stress.
So you could be making not a table with data in it, but a table designed to present some idea. Like you might put a little thumbs up in one cell and thumbs down in another. Yeah, you could do that, and that is a very useful way to summarize data, but not very exact. Now, one final question on this table: how could you simplify this table based on the findings that you're trying to present? So review the findings. By the way, is this viewable from the back now? Yeah? Okay. Fewer night people have high stress than morning and neither during the school year. But in the summer, the stress level is the same. So, what can we do to simplify this table? Quickly, a couple of ideas. Yes, in the back.
You only need 3 rows because none of the findings are really relevant to quality of sleep.
Ah, yes, great find there. We didn't say anything about quality of sleep. We did measure it in our study, and we put it in the table, but if we're trying to make the point about our findings, we wouldn't want to include that, right? Is there any situation in which we would want to include that? Can anybody think of a case where we would want to include that? Yes. Well, we actually don't know what the finding is about quality here because it didn't tell us. It just told us about the 2. But if there were a finding about quality sleep, we might want to put it in our table. But you know what? I can think of also wanting to put it there if there were no difference by quality of sleep. If I was really sure of that, I might want to say, you know what? Quality of sleep didn't make any difference. See? But these other things did. That's possible. All right, let's just quickly review a couple of other things. Oh, you guys asked, what is an observation? That is a fantastic question. And it turns out to be one of the hardest questions to think about in terms of tidy data. So let's look at a couple of these tables that we were given and say, is this tidy data? Who says this is tidy data? Who says this is not tidy data? I say it's not tidy data. Can you explain why it's not tidy data?
Because it has 2 columns, and you're only supposed to have 1 for R. Tidy data is for R, right?
Tidy data is for R.
Yeah.
You can have multiple columns in R in tidy data. In fact, some tidy data tables have 1,000 columns. I've seen them. Okay? But guess what? All those columns represent one piece of information about a single observation. The problem with this table is it's got things like summer and school year in a hierarchy, and R can't read a hierarchy. That's what we mean by you need a flat table. A tidy data table is flat. You can only have rows and columns, and each column can only be one variable. Okay? There's another reason why this is not tidy data, and this is much harder for you to see, but very important, and that is that student is being measured twice, once in the summer, once in the school year. That's actually considered 2 observations in tidy data. A way to think about it is we gave out 2 surveys. One, and then we took all these characteristics of the survey. One characteristic were what did they report stress on the survey? Another characteristic is what was the happiness on the survey? Another characteristic was who was the student who took the survey? Another characteristic was what time of year did they take the survey? So this data set in tidyr would be represented with 2 rows per student because each time they were observed, it's a different questionnaire they were given. It's a different observation. I'm trying to figure out which one I want to talk about in 60 seconds. I don't think I'm going to talk about any of them. I think we're going to quit. So this is just to get you started, but this concept is going to run through, always through your data analysis. Later in the course as well as now. 20 more questions about it next time, and we're going to dive into